would be problems that you wouldn't have the information for yet. But let's take a quick look. Everybody watch, please. Okay, just a quick review. This section is on the real zeros of a polynomial. So we only have to find the real zeros. So real numbers are numbers that don't have a what? Don't have an I in them, okay? So we're looking for every answer that doesn't have an I in it. We'll talk about the ones that do have an I in it, starting with, I think it's 5.3 or 5.4. So we will do those before we take the test on this material. So we had the remainder theorem and the factor theorem. And basically what it came down to is if we have a 0 for a remainder or we have a 0 for a function value at that point, then we know we've got a 0 and we know what the factor is that produces that. We used a graph like this. We looked at this and said, okay, if it crosses at -2 and at 1 and at 4, it's got to correspond to that factor, and that factor, and then if it asks us to multiply them out, we could do that. It talks about how many real zeros we're looking for. So if you've got a degree 3 polynomial, there could be up to 3 real zeros. If you've got a degree 6, there could be up to 6 real zeros. Okay? So we went through those, and then we had this ugly mess right here. It shows this polynomial. It's got a sub n not equal to 0, a sub 0 not equal to 0, all that sort of stuff. This big ugly mess. And how did I say you want to remember this? It's written right here. P and Q stuff, right? Okay? So if we say you want to list the possible rational zeros or find the rational zeros, that's what you're going to start with. You're going to start with the P and Q stuff. Okay? And the number at the end, that's the P. The number at the beginning, again, just the coefficient. We're not interested in whether or not that's x to the 3rd or x to the 8th or something like that. This is the P and that's the Q. And it's as simple as writing down the factors of P, writing down the factors of Q, and then writing down every P over every Q, if you want to think of it that way. Okay? And then we went through, once we had those lists, then we checked to see which ones actually work. So the word the book uses is potential rational zeros. So the way we put it was, if we're going to find the zeros, let's find the nice ones first. So these are a lot better than working with ones with radicals in them, even though some of these were fractions. Okay, this is a big long list of possibilities. Is there any way all of those could work? No, okay? Because if this is degree 3, only up to 3 of them could work, okay? And then we actually went through and we did a couple of these. So this says use the rational zeros theorem to find all the zeros. So we listed the P's and Q's. We wrote every P over every Q. We wrote that list right here. And then we checked to see which ones work. And then when we were done, we had a depressed polynomial, and then we just broke that down a little bit further. So here were the factors. Got them listed right here. And then each one of those factors corresponds to a 0. So we found 1, -5, and -4. We found that those were real zeros of that polynomial. We were looking for up to 3. In fact, we found all 3. And notice that every one of those is on our list over here. Okay, and there were, let's see, 12 possible rational zeros. And all 3 of the ones that we found were on that list. Okay, does that ring a bell? Okay. So now that we've reviewed most of this, raise your hand if you got started on 5.2. That's about half. Okay. That's about half of what I expect. Okay. So then we did this problem right here. This is problem number 47. This is very typical of what you'd see. You can be guaranteed you're going to find something like this on the exam next. When is that test? It's next week, isn't it? Should we take a look? There it is right there. It's actually on the 5th. Okay, it's on Monday the 5th. Okay, that is going to be the last test that we take for this quarter, so that will be your last and best chance to improve your grade if you're not happy with where it is. We are going to cover Chapter 6, or at least about half of Chapter 6 before we head off for spring break, which is coming up pretty darn quickly. Okay, we're sitting right here. 3 weeks from today is the Friday before spring break. That'll be the end of the 3rd term, end of 3rd quarter. Okay? Everybody good there? Okay. So that's where we left off. We did find 2 real zeros from this one. They were on our list. Okay, and did this factor right here, x squared plus 4, did it produce real zeros? It didn't. Okay, to get those you've got to do something like this, but everybody watch please. This stuff here is not in this section. This is what we're going to do in 5.4. Okay, so if you get to the point where we get something like this, this is what we call an irreducible quadratic. Okay, it can't be factored using real numbers. Okay, that's going to produce, generally speaking, imaginary solutions, and then we'd go from there. Okay, any questions? Okay, last page of your notes then. We don't have a whole lot to cover today. My goal is to get through this last page of notes, give you some time to work and ask questions and that sort of thing. If we look at the calendar, that bowling thing did kind of mess us up a little bit because we weren't able to finish 5.2 yesterday. So I don't think it's going to take both these days to do 5.3. So we're going to bump 5.3 into Monday. If we have to, it'll spill over a little bit into Tuesday. Okay? All right. Any questions? Okay. All right. So let's take a look at this. There are several theorems on this last page. Again, what's a theorem? Okay, a mathematical idea or a mathematical law that's been proven to be true. Okay, this is called the intermediate value theorem. Okay, I'd like you to cross off intermediate and write middle. Okay, that's what intermediate is. So this is called the middle value theorem. Okay, and here's basically what this says. Okay, it says that if we're going from this point right here on the left to this point right here on the right, and this one is negative and this one is positive, then there's no way that we can go from here over to here without crossing through the x-axis. Okay, we're going to cover all of the values as we kind of slide along this curve from here to here. We're going to cover all of the values on the y-axis from f of a to f of b. Okay, now the most important part of that is if this one's negative and this one's positive, in order to go from negative to positive, what point do we have to hit? We've got to hit 0. Somewhere in between there, we've got to hit 0. So if we go through the x-axis, that produces, I should have put an, x-intercept. Okay? And that's really what we're after. We want to find intercepts. And the reason we'll call this the middle value theorem is, what's in the middle of the negatives and the positives? The x-axis or 0 is. Okay, and that's why it's got to hit at least once. Now, could it do this? Okay, let me erase this guy. Could it have done this? Started here and gone like that. Does it still cover all of these values here? And does it still cross the x-axis at least once? Yeah. Okay. The opposite is true. We could start up here and then end down here. There's no way to get from here to here without crossing the x-axis at least once. Okay? Does that make sense? Okay. So, a couple questions that come from this. If a polynomial is of odd degree, what's its end behavior? So if we've got a degree 5 polynomial, where does it start? Okay, starts down here and ends up here. How many turning points can it have? Up to 4. Okay, if it's degree 5, it can have up to 4 turning points. It doesn't have to have 4 turning points. It could be like regular old x to the 5th. But the point being, if it starts down here and it ends up here, it's got to cross the x-axis at least once. Okay? It's got to cross the x-axis at least once. Does that make sense? Well, guess what? That's the next theorem. It says a polynomial function with real coefficients of odd degree has at least one real 0. So if we're working with a degree 3 polynomial, x cubed, it has to cross the x-axis at least once. It's got to have at least one real 0. If it's degree 7 or degree 9 or 23, it's got to cross the x-axis at least once. Okay? Is that true about an even polynomial? An even degree polynomial? It's not, is it? Okay? Because think about how we kind of explored this one right here. If it's odd, it starts down here and ends up here. What if it's even? Where does it start? Starts up here and ends up here. So it could come down here and then just go back up. It doesn't have to cross because the sign here is positive, the sign here is positive. It doesn't have to go through the x-axis. Okay? Does that make sense? Okay. So if it's even, we're not guaranteed a real zero. If it's odd, we're guaranteed a real zero. Okay? And then here's the last one. It says every polynomial function with real coefficients can be uniquely factored into a product of linear factors and or irreducible quadratic factors. Okay? So basically what this says is we're guaranteed we're going to be able to factor this. Okay, remember this one that we did here? We were given this ugly mess and we were able to factor it all the way down to here. We like a factor like this. We like a factor like this. We're not thrilled about something like this. This is one of those irreducible quadratics, but what could you use on this if you had to solve it? You could use the quadratic formula. By the way, if you don't have the quadratic formula memorized, get it memorized because it's going to come up a lot in the next couple sections. Okay, and it won't go away when you get to 1050 either. Okay, are there any questions there? Okay. All right. Then let's look at example 7 and example 8. Again, the assignment's at the bottom here. Remember, you don't need to worry about Descartes' rule of signs. Okay, that's how you say that. You don't say Descartes. Okay, it's just Descartes. He was a French guy. Okay, so it says use the intermediate value theorem to show that the polynomial has a 0 on the given interval. So here's all we have to do. All we have to do is prove that it either starts below the x-axis and finishes above, so it would have to cross at least once, or show that it starts above and ends below. Okay, either way, it's got to cross through the x-axis, going from one point to the other. So we're going to figure this out. We're going to figure out what is f of -1 and what is f of 0. Which one do you want to figure out first? F of 0, because if you plug in a 0, 0 here, 0 here, 0 here, so this is a 2. So what that means is at 0, at 0 the function value is 2. It's above the x-axis, and let's plug in a -1. So if I plug in a -1, what is -1 to the 4th? Positive 1. -1 to the 3rd? -1 times 8, that's going to be a -8. -1 squared is positive 1, but there's a negative out front, so that's going to be a -1 and then plus 2. So if I add those together, I can cross those off. This is going to be a -6. So at -1, the function value is -6, and what does it have to do in between there? It's got to cross the x-axis. That's it. That's your work right there. Showing that this is positive and that this is negative guarantees us that it's got to cross the x-axis somewhere in between there. Okay. Any questions? Okay. Last one then. Okay. This one says, graph the polynomial without the use of a calculator. Use end behavior, the zeros and their multiplicity, and then label all the intercepts. So this is a 4-term polynomial. It's not factored. We can't tell what the x-intercepts are right off the bat. Okay, but we are going to be able to find them. There is, however, an intercept that we can write down right away. What is it? -6. Okay, so if we plug in a 0 for x, we get out a -6. So we know it crosses the x-axis at the y-axis at -6. Okay, now we want to figure out what the zeros are. In order to figure out the zeros, we want to figure out what the factors are. Okay, because we want to figure out their multiplicity and that sort of thing. Does it touch or cross at each one of those? So let's take a look at this. This one starts with a 1 and ends with a 6. So if we're going to have to factor this, if we're going to have to find the zeros, let's find the nice ones first. Let's find the rational ones first. So what are we going to use? P and Q stuff. Okay, so let's write down what P is. What's P? P is 6. Now again, we don't worry about whether it's positive or negative. We'll take care of that in a minute. And what's Q? Q is 1. Why do we like this, Samantha? It's an easy number to work with. And how many factors does 1 have? Only 1. Okay, so let's write down the factors of 1 and the factors of 6. So this is going to be 1, 2, 3, and 6. Okay, now the great part is, once I write this down, if I do every one of these over 1, do I really need to rewrite the list? No, let's put a plus or minus in front of each one of those. Okay, let's circle that. That is our list of possible, or sometimes we call them potential rational zeros. If there are any nice zeros, they've got to come from this list. Okay, how many zeros are on that list? Let's see, 8. Could all 8 of them work? No. At most, how many could work? 3. Now here's the great part. Because it's degree 3, let's see, it's odd. Aren't we guaranteed at least one real zero? Okay. Hopefully it's a nice one. Hopefully it comes from this list. So let's go ahead and check. Should we check and see if 1 works? Okay, everybody watch, please. Okay, half of you haven't even started the assignment. If you have started the assignment, maybe you've noticed this. You can check to see if 1 works really quickly. Because remember, the remainder would be the same as the function value if we plug that point in. So if I plug in a 1, that will tell me what the remainder is. So if I plug in a 1, I get a 1, I get a 2, I get a -5, and a -6. Now, I don't really even have to write those down. Do I get a 0? I don't. Okay? So there's no way 1 works, so we can cross 1 off our list. Okay? How about -1? This would be -1. This would be 2. This would be 5, and this would be -6. So that's a +7 and a -7, so the remainder would be 0. Okay, now I like at least checking 1 and -1 by looking at it. Again, if you don't have to write this down, there's no need to. If you do, go ahead, but we'll definitely want to do this. We're going to put -1 in the box, and we're going to write down a 1, a 2, a -5, and a -6. We're going to do synthetic division. Why are we going to do synthetic division even though we know 1 already works? I mean, -1 already works. Okay, just in case, I like that. Very good, Tatum. We need the depressed polynomial in order to figure out the rest of it. All that did was find 1 0 for us. We need to find, hopefully, the other 2. So let's go ahead and do this. Again, it's bring down, multiply. That's a -1. Add, so this is going to be a 1. Multiply, that's a -1. So this is a -6. Multiply here, this is a 6. And just like we suspect, we get a 0 for a remainder. So, everybody watch, please. What does that mean about the -1? Okay, very good. I think I heard enough people say that. It's a 0. What factor does it correspond to? It corresponds to x plus 1. And then what do I write down here? X squared plus x minus 6, right? Now, Tatum, what do we like about the depressed polynomial? Very good. Okay, a couple things. This one, it factors. It's pretty easy to factor. The thing we really like is it's at least 1 degree less. So we were working with a degree 3 polynomial. Now I can just work on factoring this right here, which happens to be pretty easy. We're looking for 2 numbers that multiply to be -6 that combine to be +1. What multiplies to be -6 combines to be +1. Okay, so we're going to use a +3 and a -2. I've mentioned this before, but it's worth mentioning again. Don't take something easy like this and make a silly mistake here on a test, or on an assignment for that matter. Just take the time to double check. Do they multiply to be a -6? Yep. Do they combine to be a +1? Yep, we got it right. So, those are the factors. What's the 0 that this corresponds to? -1, -3, and 2. All multiplicity 1, so they cross. Okay? So here's what I've got. I've got -1, -3, and 2. Okay, now I don't have to write all these down, but remember, there's our complete list. Those points are definitely on our graph. So let's put them on there and let's sketch this. So, -1, -3, 2, and I could go through, everybody watch please. Sometimes that y-intercept is going to be a very big number. So I'm just going to put it down here. I'm going to put that point and I'm going to label it as 0, -6. Okay? What's its end behavior? Okay, looks like x to the third, right? So that means it starts where? Up or down? It starts down here. Now remember, when you get to -3, find the 0. Now all of these cross, so that's easy. Figure out whether it touches or crosses. It crosses here, goes through down here, and then goes like that. Okay. Take a look at all of this work right here. If that were a test question and somebody showed all that work, would that be pretty convincing that they know what they're doing? Yeah. You've shown all the work. You've shown the work in the rational zeros theorem. You've shown some synthetic division, the remainder theorem, the factor theorem, that sort of thing. You know the behavior of each one, whether it touches or crosses, and you labeled the graph each point that it crosses. Okay, any questions? Okay, there's the assignment. You've got the rest of today. Monday we're going to start 5.3. 5.3 is not very difficult. It's a review of stuff that you learned in 1010. But if you, so you've got almost a half hour right now. Get started on this. Please come on Monday with 5.2 done or nearly all done. Maybe 1 or 2 questions. 5.2 is going to be due on Tuesday. Okay? Any questions? Okay, I expect you to be working hard the rest of the time.